what could happen if you have a version control database? What does it mean? So by version control, I mean Git more than CVS or SVM. It's start directly by the new systems later. So the idea is you can. What happens if you are able to see the history of updates from the database, doing something like git log, to see every update, who did the update, what was the purpose of the update. Then if you want to synchronize to the database this together, you just do a git pull from a known source. If you want to do atomic modification of the database, you modify the staging area and then you commit -A. Then if you want to have transactions, you just create a branch, temporary branch, on which you do your changes, your commits, and then you merge the branch back. And then if you want to push your dates to somewhere, you do a push. This is very nice, and I hope everyone wants to do that. Are you really sure you want that? Because, well, if you use Git, I'm sure you already saw that kind of error messages. So you do a git pull, and then you try to merge, and then you have a big screw up. So what does it mean in a database world? So that's why you try to solve the Irmin. So the idea is everything is a library. So all the operation is described is not on the command line, but it's something which is an API that you can use. And then we have to add a way to solve the conflict programmatically. So we have some kind of way to do that. So the idea is you store in the database some typed data, and you define a merge function on that data. And as we have the full history of what happens in the database, we can use a freeway merge. That means we have the common ancestor of the data, the different forks, and then we want to converge back to the merge. A quick example about that is if you consider distributed counters, which are of type int, and I ask you, how do you merge the value 8 and 6? So what is the result of that merge? Someone has any idea?
8, 14.
Yeah, 14. Good answer. So now what is okay? So yeah, if you only two values, it's very hard to. It's impossible to merge. But if you know that, so actually you start from a common value which was 5. So what is the result of the merge? Any idea?
9.
Yay! Okay, so you took the common ancestor and you compute the diff between the two states, and then you have the final set, which is a merge between the diff from the two dividing states. And anyway, so that's everything is. So what was the link with OCaml? So everything is done in OCaml as usual. So we have a model of the OCaml heap, which various implementations. So one is Obj backend. So we use Obj magic, where values are the blocks in the heap, and the address of the key are the address in memory. And the Git backend, where the value are the blobs of Git, and the address are the hash of the blobs. So actually, they are very similar models. If you know about Git, that's just a OCaml heap, more or less, but serialized in a very specific way. And so we have a pure OCaml implementation of Git as well, if you want to use it. It's funny. And we started to implement some persistent data structure on top of that. So we opened the Kazaki book and tried to adapt all of the different implementation to add a merge function, which is specific to the kind of data you are using. And so if you have any question, I have a small poster as well. It's easy to see. Thanks.
So it's a small idea to improve